with everything, you learn from something. So next time I get a drawing from Alex, I'll know, okay then, I know there's something embedded within this drawing, in this job, that's designed to infuriate me.
Just a little stub axle, there's nothing critical on it. I won't tell the apprentice that there, but there's all these critical angles that he's going to have to do. There's going to be a thread on the end here. So what we're going to do is I'm going to hand it to one of the apprentices and say, go and make this part. I'll give him a 2D drawing. Go and make this part on one of the CNC lathes. I'll put a hole in here as well, which he'll go away and do, and no doubt do successfully. And then when he comes back and we check it and measure it and give the okay, I'm going to then tell him to go and make the same thing again, but on one of the manual machines. And I'm just going to see how his performance on that will be. We're just going to do this little test and test his capabilities on manual machines as well. And it's going to be a good experience for him as well. So, and we'll give him a hand, we'll give him some pointers. Here we go, here comes the fun. All right, who are we going to make cry today? What do you think?
Ooh. Okay.
So there's only really one diameter of the critical, and I want them to, when they're on the manual machine, they're going to have trouble with the thread and the taper. So they need to learn how to.
I reckon we can give it to Johari.
Oh, you want to give it to Johari?
Yeah.
Okay. This is Jules. He's my supervisor, but he just keeps going back on the machine. So he's a very expensive machinist at the moment as well. I mean, he should be supervising, but he loves it, don't you?
No, it's if there's an absent guy, I need to fill it in. So that's my role.
Yeah.
If it's on CNC, it will take like 5 minutes. Yeah, when it's running, 5 minutes won't.
So just
quicker. The setup will take you for like a half an hour to set up the tools, but once this one is running, 5 minutes will take. This one is easy.
Yeah, I made it easy. I just want them to. I want to see how they can perform on the manual machine. Really, I know they're capable on the CNC.
Yeah, but the manual, this will take.
That's going to be the test.
Yeah.
All right, you give it a Johari.
Joe,
when's this machine up and running?
It's ready.
Okay.
I'm just setting everything back up.
We've just got a little test thing for you.
they want to know how quick you are.
Who? Oh, okay. All right, let me touch everything off, and then I'll go to the toilet. Oh, wait. Do I get a chance to go to the toilet first?
Yeah.
All right, so go to the toilet first. I'll set this all up, take a look at it now.
All right.
Yeah, cool. All right, set everything up, and then I'll do here already.
All right, good luck.
Whoever's watching this, I'm not a slob when I work. I just, you caught me early in the morning. On to the programming. All right, so I have a shape here. This is our drawing shape. It's got to correspond to this, obviously. So we're going to make that. I have some dimensions here now that I'm going to work with. So I start at an origin point. I've already started at an origin point of 0, 0. And I'm going to bring the first thing I'm going to do is make the thread. So that has a major diameter that falls in the tolerance of 24.958 to 24.623. So I'm going to pick a number in the middle. So I'm going to go with 24.85. I'm going to add a chamfered corner so that the thread has something to lead into. That chamfered corner probably needs to be bigger than 2.5. So I'm going to make it about 3. From there, we are going to go backwards. We're going to go backwards to an unknown dimension, taper off. I'm going to taper off. In this particular dimension, it's 35 millimeters backwards to the end of the thread, minus 4.5 for a recess. So from there, I go 35, take, minus 35 plus 4.5. We always work backwards in machining. So our origin point is 0, 0. Z backwards, Z minus is every part of the material that's going to get cut, and Z positive everything that's not going to get cut. That's the free space in front of the machine, so to speak. I've already set up a value here. I'm going to make a taper. my 30.5. The angle I know is already 30 degrees, and then the X value will be 20 millimeters. From there, this machine now will add in values there, and it will begin to draw the shape. I've told the machine that we're going to make an angle that goes back to here, and from there now, I've been able to find the shape of the actual thread itself. Minus 26.3, I can delete that, and I can create a thread. Minus 26.3. Pitch itself, I know, is a 2.5 millimeter thread. So I put that inside my machine. The machine now will spit out, and it will tell me it's going to create a thread in this location. And my job is to make sure, obviously, that thread will be the right size. It'll cut accordingly. I can create parameters within the machine to give myself more room, more margin of error. Cuts it a little bit further, cuts it a little bit deeper, so that the thread will fully form all the way to the end of the base of this part. 5 mil. It sort of looks like the same thing. So that means that's what the machine now knows as everything outside the lines is the solid part. Everything inside the lines is the finished part. It's got a database within here that says what tools do we have, what's the size of these tools, what's the shape of them, how are we going to cut this all away. I do a thing called a process to side. I press process to side, machine runs its little brain, and then from there it spits out a series of different things, right? Each one, as we go past, describes what it's going to be cutting away. That's the orange or the red, pink outline of the drawing. This is the process. So this is where it's going to start, this is where it's going to finish. Now what my job as a machinist to do is to make sure the input data in here is the same as the input data on that machine's turret. So some things are not correct. For example, it's requested that I use a threading tool in position 6. I have two options. I can either relocate my threading tool to position 6, or I can keep it where it is and just change the number here to 12. It's much easier just to change it to 12, especially if it's already been touched off and it's already correct. The work's all done now. The machine has everything I've put in here I'm satisfied with. What I'm also going to do is just to make sure, I'm going to save it first because you can always just close your program and it's gone. We're going to run and test this. We're going to run this in a simulated mode first, and this is going to be a visual description. I'll put it into section mode because it makes it a little bit easier to see. And we're going to run it. This is run at a high speed, and this will show you what the actual cutting process is going to look like. So if we can make sure that at no point does this machine back into itself, does it drive itself into the part at a normal rate, or is it accidentally rapid traveling into itself? If it does that, it's going to cause a crash or send sparks everywhere. And at the same time, you can see geometric values in here, and I can see, is the machine cutting to the dimensions that I told it to? Is it cutting, a little bit more, a little bit less? Am I efficiently cutting? So if you're doing 300 of the same thing, you don't want to be air cutting too much and have tools bring in. Describes what tool's being called right now, and it's saying, what the sort of the process number is. So now into process 4 using tool 3, and it's creating the final shape at 24.85 for the thread. It's going to plunge down to 20 mil. That's also the Z value there, and it goes further and further and further. And then finally, when it's done, it's going to retract the tool, and that process is done. Now we're going to thread, so it's going to call tool 12, and this is process 5. The threading process is going to run multiple times, becoming smaller and smaller and smaller in its depth of cut, until finally it reaches the intended threaded size. And if I were to run it at full speed, it would take 2 minutes and 24 seconds, roughly. Machine, so I'm going to save that, and I'm happy with this. And now what I've got to do is I've got to set everything up in terms of a safety margin. So what I've told the machine to thread right now, it might automatically cut it an extra mil deeper. And if it does that, on certain tools, that might cause the machine simply to plunge into itself at a rate with a thickness too deep, and it will damage the machine. So, because this is the first time I've run it, I've got to make sure everything here is backed up and correct in terms of these data pages. So with all these things, I know which tools I'm going to be using. So the only things I really need to work on are those particular pages. So 1, 2, 3, and 6 are the only 3 tools that I'm going to be using. What I also want to do is check, is tool 1, tool 2, tool 3, and tool 12, sorry, not 6, are these the actual tools that I've programmed the machine to? Because again, I can say it's going to be using this tool, but when I actually want this tool, and it calls the wrong one, it's going to cause issues. It's not the right tool for the job, and it's not going to do the intended thing. So, I'm satisfied with that. I've double checked my work. I'm satisfied with the shape of the turret, the positioning of the tools in the turret, and now what I'm going to do is set up some margins and safety margins, and then I'm going to set up a 0 in my machine. So I find my tool 3, So I have different tools to do different things. Some are designed to rough and move large amounts of material quickly. Some are designed to give a very, very accurate final cut. So this is my final cutting tool. This is the one that will probably get closest to the actual chuck itself. And that's the one at most risk of getting hit. There are other ways the turret could get hit. If something sticks out here and you're busy looking at this one here and this thing is sticking out, in that direction, it could smack into something. It could smack into the back of the wall. I don't come here to break things in that way anyway. So what I'm going to do is bring my tools as close as I can to my turret, and so I can go a little bit further than that. So now we've gone past it and it's going to hit if I do that. So I can pull my tool away, set a safety, not much, that's all you need. So I'm satisfied with this. If I take any of my tools and bring it to that location, none of them are ever going to hit. Right, so that's one tool. I should mention this is only relate to the tools that I will be using. So this tool here will also be cutting, and this will also, fingers crossed, not hit. So it also misses by a small margin, that's all we need. What I'm going to do now is run a simulation. And what this simulation does differently to the previous one is it takes into account all the positions in the machine. So it's going to go, all right, if we're going to start here, is this end bit going to exceed the cutting limit? If it does, then obviously we're going to come up with an alarm saying I've exceeded my Z. At the same time, it's going to ask as well, are the geometry of your tools logical? Because I've put some things inside here, and I may be able to cut certain corners based on the tools that I've requested. So it's also going to show a nice little visual image as well. So instantly I've managed to create an error, unintentionally. And that told me that my machine was going to exceed the limit and was going to hit the chuck. So now that I've told the machine to start another 1.5 mil back that way, it shouldn't be too much of an issue. Now because I've done that, I now need to reset where that zero of that job is. But fortunately there's a quick and effective way of doing it that every machinist should know. And what I'm going to do now is call a certain tool. So if you look at the turret there, I'm going to request a different tool to come into a location. And it's going to start 1 millimeter ahead of that new zero position. So you get real close, but it's going to be about 3.5 millimeters from the start of the job. There. So now, I'm going to unclamp my part, slide it back into that position. Now, this face now is 1 millimeter ahead of the start. So what's going to happen now is when my first tool in, it's going to cut, hopefully, 1 millimeter off the face of this job. And then from there, we are going to see some machining. So we're going to start the program. Machine's going to go back to its home position. It's going to spin up, turn my coolant off, and we're going to see the first process. I'm going to stop right there, and I'm going to check on my data page just here that these numbers are corresponding with where the tools are in relation to the start of the job. I'm pretty satisfied with what I see right there. It's about 5 millimeters. Machine says 5 millimeters or 4.9 roughly. So we're going to go to that first location. We're going to start cutting. So I've paused, I'm holding the machine in this location, and my job as a machinist is to use this speed control to make sure the machine does what I request it to do. And we can see there. And then it's going to return back to a home position. I'm going to check it, make sure everything's nice. And the machine isn't making any, what we call tits, which is the when it's not running true to center. So far that tool's good. Next thing I'm going to do is now request a second tool. So I hit the cycle start button, and the cycle start button pulls the tools into the location, and it'll do the same thing. So it will now move into location here. I visually check and make sure that corresponds to what I've requested on my machine. And if I'm happy with that, I let the tool go, and it will start to cut. And the only thing I want to do is keep an eye on towards the end of the chuck. It's getting real damn close. But it didn't hit. So I like to look at these numbers on here, and then test my tools to make sure what's actually being cut is indeed 25.20. So I have micrometers here. I've already set these to 0, so I know they're running true to size. And because I've backed everything up, I don't know what this machine's going to be cutting through right now. See, so there's some shiny, nice parts here already. But this is just the roughing process right now. So this isn't super critical, but the machine, I've told the machine to cut a certain amount. Cut it away and then leave me 0.4 of stock to do my final pass. That might matter on certain kinds of jobs where there's a certain expectation of finish. I can always double check my work or use a vernier. But what was supposed to be 25.25 is actually 26.0. So I need to shrink my actual tool height by that amount. So I take this number here, which is my offset, and I add minus 0.75, and that will give me now an offset, hopefully pretty close to my intended cutting size. So what I'm going to do now is I'm actually going to just finish the part, but now I've calibrated that part of the job, that part of that particular tool. So in my tool 3, it's still got a massive offset to give myself a large margin of error just in case. So I'm going to continue to run the process, but I know this is going to make a part that's oversized right now. So now it's going to change speed, call a different tool, and it's going to come into the location and do the same thing as it was doing before. It's going to face it first, then it's going to retract, it's going to stop, and then it's going to do the next part of the job, which will be the outside diameter. This will be a significantly lighter cut because it's supposed to produce a much finer finish. It's going to be running at a different speed and a different rate and a different RPM, or different feed rate, should I say, in order to produce the finish that I've requested, which is a nice, fine, smooth finish. You're going to get real close to the chuck and it's going to pull away. I'm going to check these dimensions. I have a couple of critical dimensions on here. We've got one here that wants to be 45 millimeters plus 0.03. So that's not a lot of margin of error to work with. We're talking hundredths of a millimeter there. So I'm going to bring my micrometer. That's the most critical dimension. That's the one that's most important. So I'm going to check to see if that's true first and foremost, and then I'm going to work backwards from there. Reading this particular micrometer, it says it's 45.72. I'll check it up. I'll double up with 2 tools. Yep. This one's slightly off, but it says 45.66. But I trust that thing a lot more than I trust this. So 45.72 tells me I can just use a calculator. I know this is supposed to be 45.03. Okay, 45.72, take 45.03. And it tells me I need to take 0.69 millimeters off there. More than numbers it could have been. But I'm going to check out a couple other things as well and make sure these things are true to size. So I know this major diameter is supposed to be 24.958. Or to 24.623, somewhere in that range. I've told the machine 24.85. So now we're going to see, is that also running out? So right now this looks to be about 25.55. So I go, or 25.56 should I say? 0.71. So it's in the same ballpark, but I'm going to go with a critical dimension. So I'm going to take it down by 0.69, and that's going to give me, hopefully, everything else will correspond to that. That's the most critical thing. That's the bit that needs to fit into something. So now I go to my page again, and I take this number, which is 0.6 right now, and I deduct minus 0.69 from there, and I get an offset now of minus 0.09, which is roughly what it was before. But we're also only looking at one plane of movement right now. My machine possibly could be cutting wrong in the other direction, so it's most likely not, but it's always worth just giving it a check. So 35.03. I can also program it incorrectly, so that's another reason why you always want to check it. And this other dimension is 37 backwards. So I'm pretty satisfied with all this right now. So I'm going to go run that process again, the outside dimension, to bring it true to size. If I just press the green button, it would call the threading tool and it would begin to thread. But we're not doing that just yet. So I'm going to 45. So we're actually still a little bit oversized. As to why that is, tools do wear. So it is a surface that's being cut, and it is cutting away slowly as it runs across the part. So it could be that. It's a brand new insert, so it's nice and sharp right now, and sort of, if you think of a knife, the first cut is the sharpest, and then every cut is going to be blunted after that. So I'm going to run that again, and I'm just going to take off a small amount. But there also may be other reasons why it happens, and those reasons are complex and confusing and relate to the geometry of the machine. I have just calibrated this thing, so I haven't had a lot of time to run it all in and make sure everything is doing the things that I want it to. So as much as I am fairly certain now that it's going to be a correct part, this is the only thing that matters. If it doesn't say it on this, then it didn't happen. You've made something wrong. Yep. So if you look at the micrometer there, it's now reading 45.0152. So pretty much right in the middle, which is where you want it to be. So the next thing now to do is start to cut a thread. And what it will make is something that doesn't visually look exactly like a thread just yet. It'll be a bit sort of chunky and oversized. And that's because I've given it quite a large sort of margin of error. So if you look at that thread right now, it doesn't quite look like the way it should. So I've got a fair ways to go. I sort of know that visually. So the numbers I'm looking for are 23.334 to 154, which is what I got from the machine earlier. And it's bang on 24. So I take 24, deduct the higher side or the middle side tolerances. But what I'm going to do now is I'm going to flip the part, because we're only halfway through. A little bit further than halfway through, but we're currently only halfway through. This part needs to be 90mm long, and right now it is something close to 107. So I'm going to get some 45mm jaws. So now what I'm going to do is take my old jaws out. We take this part out and we look at the drawing that we have here. We can see that everything on this side's good. We really just need to make I've already got a chamfer there. All I need to do is make this part here 18mm long from here to here. So the first thing I'm going to do is make sure this plane here is flat. So I clamp it back in there. First thing I'm going to do is skim it, and then I'm going to take it to a piece of equipment over there to measure it. Now the material's nice and flat, I'm satisfied that I can measure off this. So now I'm going to take it with my verniers, and we can see, if I try to hold it as best as I can, it's about 106.55. Now I want to get this as close as I can to that final dimension of 90mm. So I'm just going to do a bit of math. So that's how much I'm going to have to skim off and then make a chamfer for. That's all that's requested. I've just got to cut off this material until we reach here, and then form a corner, and that'll be the final part. I like to get my final cutting tool, bring it to the front of the job. And there are sort of different ways to go about this. I'm going to clean it up, and I'm going to get a piece of paper. I'm going to use a piece of paper as a visual guide, which I don't have anymore. This piece of paper is about 0.1mm long. Thick, should I say. So I'm going to bring this piece of paper into the front of this job. I've already measured this as 16.55. I'm going to take it into there, and as soon as it bites the paper, so that bites there like that, it's holding in place. So now I'm going to tell this machine, this is my new starting position. I'm going to take a certain offset value, put that into the machine. So this is my starting position. The paper is 0.1, so now I'm going to deduct another 0.1 for the paper. And then my final cutting size was 16.55, so I'm going to deduct 16.55 from there. One last thing I could do, and I will do, just because it's for the purposes of, knowledge, is I'm going to make sure that my Z limit doesn't exceed the limits of these jaws. Now these are all standard jaws, so hopefully that shouldn't happen anyway. And I just visually look, and I brought my tool as far as I can. I can go no further, and I can still see there's a little gap of air here, meaning whatever I do, it isn't going to exceed that point. So there's no real risk of a crash, at least into the chuck itself. Cool, so I'm satisfied with that. My machine now believes 0 is somewhere inside here, somewhere a little bit past the job, and it's going to do those first 17 cuts until it reaches that point. So now we start. I put my machine back into a test mode, and I test position by position. Right now it's locked. Nothing's going to happen, but it's going to, what I first need to do is load the right program. Test part 2. Okay, we'll say at the top here, test part 2. Hit reset, close, press the first button. And now we'll do the same thing I was doing before. And before I take it out, I can always just check that this little bit here is 18. You can't always measure the entire part when it's already clamped in, because there are certain parts that are now obscured from you because they're hidden behind the jaws. But my verniers say 18.0, 18.03, 18.02, depending on what angle I hold it at. We have a better tool for measuring it all, but I'm satisfied with this. And first and foremost, before you take it to any measuring gauge, does it look like the thing that you're trying to make? So this is the height gauge. All right, it goes to 0. There we go, 0. First height. Very, very close, 90.003, 90.005. Pretty much it. So now I work backwards. I can work from this dimension here. Is this 18? 18.03. Right. This bit here is 18 plus 37, 55. And also I can always work backwards here by zeroing it off here. This tells me 35, 0 off there, 35, and it should be 37.
Something, also look, I'm looking at that taper.
Yep.
Doesn't look right.
Because it says 1.545.
Yeah, and then 30 degrees there.
Yep.
Is that 30?
Should be.
Looks a bit out of scale to the drawing.
Oh. Program does 30 though. I'll check.
Just check that.
Yep. I see what Alex has done.
We do have face grooving tool.
He hasn't made it at 30. It's a 30-degree taper shape.
If anyone wants
Is it aluminium, that job?
Want to start again?
Oh,
Motherfuckers. Why would you do this to me? All right, cool. Thanks, Alex. All right, back to the... All right, should we... Fuck it.
need anything for a little tiny...
All right, so what's happened is I've gone and, immediately just stuck a piece of material in and started cutting, basically. So there are many, many ways to describe drawings. Things need to correspond. You knew what you were doing, weren't you? No, okay, because you also chain dimension things. I'm like, what is going on here? Yeah, so I made 30 degrees, but it's supposed to be 15 degrees, depending on how you describe things. So there's more than one way to skin a cat. People who do this go in my bad books usually as far as customers go. So if you bisect this part in half and you make an angle from here, this angle itself is 15 degrees to this plane here. So 15 degrees there, 15 degrees there, and if you add these two up, you get 30 degrees.
Yeah, now you can't just keep blaming everyone else.
No, I can't.
It's included. You can see an included angle there of 30 degrees.
All I want to do was calibrate my damn machine. But no, okay. All right, should I start again?
Yes.
All right, cool. All right, I'll go find material.
Won't take long this time.
What?
It won't take long this time.
No. I have 90% of the work done. Okay, so what do we have on the shelf here that's perfect for the job? I suppose it doesn't have to be 4140, we can just find something else. Might have something else here. Oh, we have aluminium. This job is humbling. It's taught me a lot of things about life that but a lot of those things that old people used to tell you. Measure twice, cut once. If it's a job worth doing, it's worth doing well. Efficient time saves 9. All these things are true. Because there's no calibration this time, it should be fairly fast. I can pretty much just run it first time, and it should be pretty damn close. And the other thing is, because it's aluminium, I can run it much, much faster. The only thing I'll need to do for this actual side of this size is, apart from change the actual dimensions of the job, is I have to just tell the machine that I've got a bit more material, because I'm not working with 55, I'm working with 60 this time. So, in order to do that, put my drawers back in, take the old ones out. All right, so what I'm going to do visually different this time is I'm going to cut it off, or I'm going to put a nice big parting mark on it, and that should be hopefully pretty damn close. But I'm going to do the entire shape in one go, and then put a parting mark, and then basically just take it to a bandsaw and cut it. There's really not much, and then just come on face the last little bit and make it nice and good. So, what I'll do is I'll give myself 1 millimeter margin of error. So now we're going to test it. Now I can speed this up quite a fair bit because it's aluminium. It's just a softer material, cuts differently. But because it is a different material and I have changed a few things, it's always a good idea just to give yourself a bit more offset margin of error just in case it cuts deeper. So I'm going to do that again. I'm just going to back off certain tools by 0.2. But as you can sort of see here, it's going to make a little parting mark. That parting mark is 91 millimeters from the edge. This part's 90. So when I flip it over, just bandsaw it or even hacksaw it off and do the cut on the other side. Just flip it over and just skim that last millimeter off. So once again, it's not going to crash. Load up the new program, now run it in test mode. The things I go through so you guys don't have to, whoever is watching this. Oh, doesn't that look beautiful? That looks exactly like the drawing this time. Angles and everything. Have a nearly completed part, just a little bit there to cut in. So go down to the bandsaw, cut it off, measure it all up, and just flip it, and basically that's it. All right, this is scrap. This bit here should be 1 mil longer. That's what I requested the machine to do. So I'll take it to the height gauge and just check it. Yeah, 91.04. That also tells me my tool is ever so slightly offset. So that should be almost perfect. Should actually be 91, but for whatever reason, the grooving tool itself, sometimes when you touch it and what it actually cuts and what you touch it off, it's always just slightly off. So I can add an offset to that. This, it gives me information about how my machine's actually operating. So I can go to an offset page right now, which is my tool 4, and I want to add minus 0.04. Now, when it cuts, it's going to shift over by 0.004 millimeters. So next time I do this job, hopefully never again, will be 91 exactly, or 90 exactly, right? So now all I need to do, flip my jaws, put the old ones back in, and take off that last 1 millimeter.
Are we done yet?
No.
We're not done yet.
So here we have 2 bits of material. The aluminium one's correct. The steel one is incorrect. So what we have here are 2 angles. This is a specific, so this is obviously the little point of contention. This angle here is correct, and this angle here is incorrect. I don't quite have a tool that perfectly describes it, but if you see square to here, where's my set square? Here's a square, and you can sort of see the angle that's included in here is a different angle to this. There are a couple of ways we can visually tell. Because this angle has a start point and a finish point, that one there is a lot further across than this one here. That suggests to me that this is a shallower angle than this, ramping up 15 degrees in accordance with this plane here, whereas this one here is ramping at 30 degrees. Now there are 2 ways of describing this angle and this angle. So you put that together in a protractor of some sort, it would be a 60-degree angle. If you do that with these, you'll get a 30-degree angle. And so different engineers draw different things in different kinds of ways. I can't tell you exactly the right way to do it. I have the way that I'm familiar with and the ways that I usually see. This is not making excuses. So sometimes when little things like this happen, I can gloss over them. And again, it's your job as an engineer and machinist. Your time spent doing this, should it be weeks, months, years, decades, will prepare you better for these kinds of situations where things are done the ways that you're not used to. Hopefully you learned something from this, but I'm sure I'll see you one day stuffing things in the bin like I'm about to do with this thing.